Okay, the second part that was left from 6.2 is combining methods. So you're welcome to, again, look at that handout. So I'll share the screen just in case you didn't watch the first video and you're just looking at this one. This is from the handout that we distributed in class, and we're going to look at these examples now. Factor the following, which is combining methods, and also solve the following, which is also combining methods, but then we make it equal to 0. So these are the examples that we will go over. The first one was solved in class, so I'll just review that, and then we'll move on to the next 4, okay? And now I'm sharing the iPad. I don't know if you can see, but it's right there, right there. Okay, this is good now. Paying attention to everything. This is the first example from this section. It was 3x times y squared plus 3xy minus 6x. The first thing that we did here was find the greatest common factor. And we did that, and it was great. It was 3x, and then we multiplied that by y squared plus y minus 2. And this is a quadratic function where a is 1. So that's the first method that we talked about for trinomials, b 1 and c minus 2. So we were looking for two numbers. So we're looking for two numbers that add up to b and that multiply to c. So two numbers that satisfy those rules are -1 and 2. And therefore, when we factor, we have y minus 1 times y plus 2, which is what is highlighted. And we multiply that by 3x because we had 3x as the greatest common factor initially. Now, moving on to the next example, 5y squared minus 80. The first thing that we want to do is attempt to find greatest common factor. So I'm going to do that. I'm going to have 5y squared minus 16. This y squared minus 16 looks very much like one of the special cases, a squared minus b squared, where a, for this case, is y, and b is 4. So from before, we said that a squared minus b squared, if we factor that, it's a plus b times a minus b. Sorry, that did not fit there. So if I apply that to this case of y squared minus 16, where I figured out that, let me highlight this. I figured out that a for this case is y and b is 4. Then y squared minus 16, applying what I know that for a plus b and a minus b, would be y plus 4 times y minus 4. You're welcome to rewatch or slow down or do it again if watch it again if you need to. But this is one of those special cases, and I still have the 5 from the greatest common factor. I have y plus 4 and y minus 4, and this will be my answer. Okay, so again, I used one of those rules from the special cases where I know that a squared minus b squared is the same as a plus b in parentheses multiplied by a minus b in parentheses. For the next problems on your handout, next title, I believe it says solve by factoring. The first one, we have w squared plus 11w plus 18 equal to 0. So this is one of the trinomial cases where a is equal to 1. I have that b is 11, c is 18, and I'm trying to find greatest common factor, but this is not something that I can find here. It will be 1, so it wouldn't be helpful. So I'm looking for two numbers that add up to 11 and multiply to 18. And those two numbers will be 2 and 9. If I attempt 3 and 6, they multiply to 18. They don't add up to 11. So two numbers that make that true are 2 and 9. Therefore, this factors out as w plus 2 times w plus 9 equal to 0. And this happens when w is -2. It also happens if w is -9. Okay? Because when w is -2, this is 0. When w is -9, this is 0. So as long as one of those two is true, then my whole expression will be equal to 0. Okay? Already been 4 or 5 minutes. So let's move on. I have now example B. Whoops. And you can skip the examples if you feel comfortable with it already. You say, you know what? I'm good. Okay. I have 6m squared plus 12m minus 144 equal to 0. Now, for this example, which is one of the last examples that we'll see, you could use the AC method. That's fine. However, I'm going to try to find, are you guys seriously going to work on plotting the graphs right now? I'm going to attempt to find the greatest common factor first, okay? And I'm going to use my trusty calculator, just so I don't make a mistake. I'm going to see if 6 is the greatest common factor. So let me see, divide 144 by 6. Oh, I get 24. So yeah, I'm going to try that. I have 6m squared plus 2m minus 24 equal to 0. Okay, so if I can factor that m squared plus 2m minus 24 equal to, then make the whole thing equal to 0, then I don't have to use the AC method. So here I have that b is 2 and c is negative 24. So then, I gotta start looking for two numbers where that is true. With two numbers I multiply to c, I could use 12 and negative 2. That doesn't add up to 2. I could use 8 and negative 3. And that does not add up to 2. I could use 4 and negative 6. Oh, these add up to negative 2. So I must be close, so I'm going to use negative 4 and 6. My two numbers, they multiply to negative 24. And they add up to 2, okay? So then I would have 6 multiplied by m minus 4 multiplied by m plus 6 equal to 0. And this happens if m is 4. And it also happens if m is negative 6, okay? So this already has been about 7 minutes. So you're welcome to stop watching. We'll do one more, okay? But it's just extra practice. Here we have 10x squared minus 105x plus 135 equal to 0. And I cannot divide 135 by 10. Well, I can, but it's not going to be helpful. So looks like I'm going to have to do the AC method here, okay? I'm still going to find the greatest common factor because I can, all right? So it looks like it will be 5 because I can't use 10. So I have 2x squared. 105 divided by 5 is 21. 135 divided by 5 is 27. And this is equal to 0. So this over here is what I'm going to factor using the AC method, where A is 2, B is negative 21, and C is 27. I don't think I finished this problem on the notes that I posted. 27, okay? So I multiply A times C. That was step 1. I'm not writing step 1 just so I can move faster, but you can look at the steps. So you should, because this is one of your first times practicing this. So A times C is 24. So I'm looking for two numbers that add up to 24. Where is it? To 54, my bad. Add up to 54. I don't know what I said. And multiply. My bad there. I'm trying to rush and then I'm just saying something that's wrong. I'm going to add up to negative 21 and multiply to 54. There we go. All right, multiply to 54. I'm going to start trying to figure this out using blue. I have 9 and 6 multiplied to 54. No combination of that. I'm going to do negative numbers here since I have negative over here. That does not add up to negative 21. What about 54 and 1? Definitely doesn't add up to 21. What about negative 18 and negative 3? Oh, they do add up to 21. So those are the ones that, or to negative 21, okay? Those are the ones that I'm going to use. Oops. And that means I have, using the AC method applied just to this part, okay? I'm not using the 5 this time. I have 2x squared. I'm still there. I have minus 18x. I have minus 3x. And I have plus 27, okay? I'm not done. Now I have to do factor by grouping, okay? And that was step number 4, if I remember correctly. Step number 4. Expanding was step 3, and this is step 4. Here I have 2x, x minus 9, have -3, x minus 9. What is common? X minus 9. What am I multiplying that by? 2x minus 3. And I still have this 5 from the original equation. And all of this is equal to 0. Now that I have prime factorization, let's remember that phrase, then I can say whenever 2x minus 3 is 0, that will give me one solution for x. Don't know why this is writing like this. It's supposed to say equal to, okay? And whenever x minus 9 is 0, it will give me the second solution for x, okay? Thank you for watching and for your patience. I know this is longer maybe than you wanted it to be. So take care.